Let us continue hydrogen and its compounds, in which we will see hydrogen peroxide. Now we will take manufacture of hydrogen peroxide by electrolysis. In the electrolysis method, we are taking electrolyte 50% aqueous solution of sulfuric acid. This sulfuric acid undergoes ionization. This sulfuric acid undergoes ionization to give H plus ions and HSO4 minus ions. HSO4 minus ions. Sulfuric acid structure we will see. Sulfur we will write and 4 oxygens. 4 oxygens. Then the sulfuric acid is a oxy acid. It is oxy acid. Oxy acid means OH group will be there. That OH group gives H plus. Then it is a dibasic. Dibasic means it gives 2 H plus ions. Therefore, both hydrogens present in the form of 2 OH groups. Therefore, 2 hydrogens right with oxygens. Now we will give bond. Hydrogen always make single bond. Oxygen will make double bond. Otherwise, 2 single bonds. This is sulfuric acid. Sulfur belongs to 6th A group. Sulfur belongs to 6th A group. Therefore, its valence shell contains 6 electrons. So it is making 6 bonds. Okay. Next, in this sulfuric acid, this bond is migrating. Therefore, this becomes O minus, this becomes H plus. It is called ionization. So sulfuric acid on ionization gives H plus and HSO4 minus. So how the structure of HSO4 minus will be there, that we will see. Now we will write everything same. Here O minus we have to write, here H plus we have to write. Between them no bond will be present. Like that we have to write. So O, S, O, O, H, O. Okay. Now here double bond, single bond, single bond, single bond, minus charge. Here H plus. It is called ionization. This is called a bisulfate. This species is called a bisulfate. Okay. Then this H plus cation goes towards the cathode and takes electron and becomes hydrogen atom. This hydrogen atom combines with another hydrogen atom to form hydrogen gas. So hydrogen gas is liberated at cathode during the electrolysis. Then this bisulfate goes to anode. Bisulfate goes to anode. Anode will receive electron. Bisulfate goes to anode and loses electron. So this bisulfate will write, that is a HSO4 minus. HSO4 minus we are writing like this. Here we are writing like this, negative charge. Now it is donating this electron. This HSO4 minus donating 1 electron. Yes. Therefore, negative charge is vanished. Negative charge is vanished, we can say. Now we can say this oxygen valence shell contains 5 lone electrons and 1 bond. 1 bond means 2 electrons. Totally 7 electrons. This valence shell contains odd number of electrons. Therefore, it is called a free radical. Okay. Now we will consider another free radical. Another bisulfate gives another electron and becomes free radical. That free radical we will consider. So we got 2 bisulfate free radicals. Okay. 2 bisulfate free radicals combines with each other through bond. Like this bond is produced. Therefore, we are getting H2S2O8. It is called a Marshall's acid. It is called a Marshall's acid or peroxy disulfuric acid. Why we are saying peroxy? Because here O single bond O is there. It is called peroxy linkage. This we will call it as a peroxy linkage. So peroxide is present here. Therefore, it is called a peroxy disulfuric acid. We can call this is as a peroxy disulfuric acid we can call. Okay. So peroxy disulfuric acid formula H2S2O8. Now we will take this anodic product. This is anodic product. This anodic product we will take for vacuum distillation. We are taking this peroxy disulfuric acid for vacuum distillation. What we will get, that we will see. So this peroxy disulfuric acid we are taking for vacuum distillation. So we are getting which substance we will see. Now we will write structure of peroxy disulfuric acid. Peroxy disulfuric acid structure we have written. Now it is going for which one in the sense vacuum distillation. Now what is happening means, now this bond is breaking. In the water, H plus is attacking here, OH minus is attacking here. Therefore, this part becomes what in the sense sulfuric acid. So that part becomes sulfuric acid. Next, this part is what in the sense H2SO5. It is called Carose acid. It is called Carose acid commercially. How this Carose acid formula will be there, we'll see. The Carose acid formula will be like this. Carose acid formula will be like this. It undergoes further distillation. It undergoes further distillation. Here what happens means this bond is breaking. OH minus coming this side, H plus coming this side. Therefore, this becomes hydrogen peroxide, H2O2, and this becomes sulfuric acid. So we are getting hydrogen peroxide. Okay. So here what is the electrolyte we have taken? 50% aqueous solution of sulfuric acid. This on ionization gives H plus and HSO4 minus. H plus goes to cathode and becomes hydrogen gas. HSO4 minus goes to anode and becomes Marshall's acid. Marshall's acid is having peroxy linkage here. It is peroxy linkage. This Marshall's acid undergoes vacuum distillation to give sulfuric acid and Carose acid. This Carose acid is called peroxy monosulfuric acid. Peroxy, where peroxy linkage is there. Peroxy because peroxide linkage is there. Monosulfuric acid we are seeing. This on further vacuum distillation gives, this becomes hydrogen peroxide, this becomes sulfuric acid. So we are getting hydrogen peroxide. This is the method used in industries. Okay. Next method we will see. In the next method, electrolyte is what? In the next method, what is the electrolyte? That we will see. In the next method, we are taking electrolyte aqueous solution of ammonium sulfate and sulfuric acid. Ammonium sulfate and sulfuric acid is the electrolyte. Now we are going for next method of electrolysis for manufacturing hydrogen peroxide. Now we have taken ammonium sulfate and sulfuric acid aqueous solution we have taken. This ammonium sulfate and sulfuric acid we have taken, both will combine to give what? That we will see. Ammonium sulfate and sulfuric acid both combines to give which one? That we will see. Both combines to give ammonium bisulfate. Both combines to give what in the sense ammonium bisulfate. How this ammonium bisulfate is produced? That we will see. Now first we will see ammonium sulfate formula. This ammonium sulfate NH4 twice SO4. Sulfuric acid is H2SO4. Sulfuric acid structure we know that is here 2 times double bond O, here OH, here OH. It is sulfuric acid. In that, in the place of this hydrogen, what is there? Ammonium ion is there. That's all. Okay. So now we will write ammonium sulfate S double bond O, S double bond O, O, O. In the place of hydrogen, we will write ammonium ion NH4 plus. Okay. In the place of hydrogen, we have written what in the sense ammonium ion we are writing. We are writing ammonium ion means we have to give minus charge to oxygen. This is called ammonium sulfate. When it is going for ionization, what happens means this bond is shifting. This H plus is going here and ammonium ion coming here. So what you will get? Ammonium bisulfate you are getting. Okay, that ammonium bisulfate, how it will be there? That we will see. Here double bond O, here O minus, NH4 plus, here OH. It is called ammonium bisulfate. So we are getting a what in the sense? Ammonium bisulfate we are getting. So you are taking electrolyte, ammonium sulfate and sulfuric acid aqueous solution you are taking. You are mixing them. They are converting into what in the sense? Ammonium bisulfate. Okay. Now we will take ammonium bisulfate. This ammonium bisulfate is going for ionization. This ammonium bisulfate is going for ionization to give what are the ions in the sense one is H plus, one is H plus, another one is what in the sense NH4 SO4 minus, NH4 NH4 SO4 minus it gives. How we are getting this? This ammonium bisulfate on ionization gives H plus and NH4 SO4 minus. We are saying no. How we are getting this? That we will see. Now this is ammonium bisulfate. Here what happens means on ionization this bond is shifting. Therefore we are getting O double bond S double bond O. Here O minus NH4 plus. This is O minus, here H plus. So this ammonium bisulfate on ionization gives H plus separate and NH4 SO4 minus. Okay, like this we are getting. So therefore ammonium bisulfate on ionization gives H plus and NH4 SO4 minus. This H plus goes to cathode and becomes hydrogen gas. This NH4 SO4 minus goes to anode. This NH4 SO4 minus goes to anode. So NH4 SO4 minus goes to anode and loses what in the sense and loses electron. Now we will see NH4 SO4 minus. We will see now this NH4 SO4 minus, how it will be there. What is the structure of that? That we will see. This NH4 plus O minus. This SO4 minus will give SO4 minus. This is NH4 SO4 minus. It is going to anode and loses electron. It is losing electron in the sense negative charge will be vanished. It loses one electron. Okay, it has lost one electron. So then it becomes what we will see in this oxygen. Valency shell contains 7 electrons. So odd number of electrons. Therefore, it is free radical. We are getting another free radical. Another NH4SO4 minus loses one electron and become like this. And become so and so. So another one will take like this. So another NH4SO4 minus loses one electron and becomes like this. This is free radical. It is free radical. Between them, a bond is produced. This is called what? What is the formula of this one? This formula is NH4 twice S2O8. NH4 twice S2O8 we are getting. NH4 twice S2O8 we are getting at anode. So at anode what we are getting means NH4 twice S2O8 we are getting. At cathode what we are getting means hydrogen gas we are getting. Next, this NH4 twice S2O8 we will take for vacuum distillation. This we are taking for vacuum distillation. So in vacuum distillation what we will get? That we will see. In vacuum distillation what is the substance we will get? That point we will see. So we are taking NH4 twice S2O8 we are taking. NH4 twice S2O8 we have taken this for vacuum distillation. Okay. Now that structure will write NH4 twice S2O8 structure is this. NH4 twice S2O8 structure is this. It undergoes hydrolysis. It undergoes hydrolysis like this. This bond also breaking. Here OH minus, here H plus. Therefore, what we are getting now? What is the product we will get? This on this NH4 twice S2O8 on vacuum distillation. We are getting at center you see in the structure at center you can see hydrogen peroxide. Here what we are getting means hydrogen peroxide we are getting. This is what in the sense NH4 HSO4. This is also NH4 HSO4. So we got hydrogen peroxide. Then this NH4 HSO4 is called ammonium bisulfate. This ammonium bisulfate on ionization gives H plus and NH4 SO4 minus. So again process continue. Therefore we are getting what in the sense that means what is consumed, what we are getting. What is a net reaction? This NH4 HSO4 is produced, that goes for ionization like this. That goes for ionization in the sense we are getting again hydrogen peroxide we are getting. That means what is a net reaction? Net reaction is what is converting into what? Here How many water molecules means 2 water molecules we are trying to unbalance. That means shall we say net reaction is 2 times water molecules converting into hydrogen peroxide, shall we say? Yes. The water molecules converting into hydrogen peroxide is the net reaction. Sorry. Next we will see next method of preparation of this hydrogen peroxide we will see. Next method is what in the sense auto oxidation. Auto oxidation. In this method, what are the substances we are taking in the sense? One is called 2-ethyl anthraquinol. 2-ethyl anthraquinol we are taking. So first we will take anthracene. We will take first what we will take in the sense anthracene. That means this is benzene. This is naphthalene. This is anthracene. So now we got anthracene. We got. Sorry. Next, anthracene. What is meant by anthracene? We got. Anthra is there no here? Anthra. Anthra means anthracene. Then we will see about this quinol. Okay. Now another substance we will take 2-ethyl anthraquinone. Now we'll see quinol and quinone. We'll see this quinol in the sense this is quinol. Benzene having 2 H groups at para positions. This is called quinol. Now we will make this is as quinol. Okay. So in the anthra we have made quinol, anthraquinol. So here also anthracene. We will write anthracene. Anthracene we have written. Then quinone is there. What is quinone? That we'll see. Quinone is this. It is quinone. Okay. So we will make here quinone. We will make. So we'll make what in the sense quinone. We'll make it now. So this part is quinone. So it is anthraquinone. Sorry. Now we know what is quinol and what is quinone we know. So from that we said anthraquinol, anthraquinone we said. Next we have to say 2-ethyl. That means here we have to give numbering. How to give numbering means it is number 1. Number 1 we have to start here only in anthracene. It is number 2. At number 2 you give ethyl group. Et means ethyl. C2H5 like this we can say. So here also you have to give number 1 here, number 2 here. At number 2 you give ethyl. So 2-ethyl anthraquinol we have taken. 2-ethyl anthraquinone we have taken. Now we are going for what in the sense auto oxidation. For what case? In order to prepare, in order to manufacture hydrogen peroxide. Okay. So now first we will see. First we will take a 2-ethyl anthraquinol. We will take for auto oxidation. 2-ethyl anthraquinol we are taking. Ethyl anthraquinol we have written. Now 2-ethyl anthraquinol. It is exposed to atmospheric air. This is exposed to what in the sense? Now it is 2-ethyl anthraquinol. It is exposed to atmospheric air, so it is undergoing oxidation. Just exposed to atmospheric air, that's all. It is undergoing oxidation. How the oxidation will be there, that we will see. Now this bond is migrating to this place. This is migrating here. It is migrating here. This bond is migrating here. Now this hydrogen and oxygen becomes hydrogen peroxide. Hydrogen peroxide we got. Next, what is the remaining? We'll see. Now, here 3 pi bonds are there. Those 3 pi bonds we will write. Here, this pi bond comes to this place. And here pi bonds, here double bond O, here double bond. So we got 2-ethyl anthraquinone. We got 2-ethyl anthraquinone we got. Then this 2-ethyl anthraquinone will take this 2-ethyl anthraquinone we are taking. Anthraquinone. To this hydrogen gas is passed and the catalyst is placed. Catalyst is a nickel catalyst or palladium catalyst or platinum catalyst, and a moderate temperature we are providing. Moderate temperature we are providing. So what we are getting, that we will see. What we are getting. Okay. Now we are getting a 2-ethyl anthraquinol. We are getting 2-ethyl anthraquinol. We are getting here ethyl group, here OH group, here OH group. 2-ethyl anthraquinol we got. So this quinone undergoes a reduction to give quinol. 2-ethyl anthraquinol we got. What is a net reaction here? What is a net reaction in this one? That we'll see. Now what is getting cancelled? That also we'll see. 2-ethyl anthraquinone, 2-ethyl anthraquinone getting cancelled. 2-ethyl anthraquinol, 2-ethyl anthraquinol getting cancelled. So what is the remaining in the sense? This hydrogen plus this oxygen and a catalyst nickel palladium platinum, moderate temperature, we are getting hydrogen peroxide. So net reaction says that hydrogen combines with oxygen in the presence of catalyst to give hydrogen peroxide. This method is called auto-oxidation. Why? Because this 2-ethyl anthraquinol undergoes oxidation with atmospheric air directly without any need of any catalyst or any external agency and giving hydrogen peroxide. Therefore, it is called auto-oxidation we are seeing. Then we will see concentration of hydrogen peroxide. Concentration of hydrogen peroxide. Now, we are preparing hydrogen peroxide in the sense we are getting hydrogen peroxide aqueous solution we are getting. In the auto-oxidation, no water is there, therefore we are not getting aqueous solution. But in the rest of the cases, we are getting aqueous solution of H2O2 in the rest of the cases. Okay, so we are getting aqueous solution of H2O2. In this aqueous solution of H2O2, how to remove the water and how to get hydrogen peroxide crystals, that we'll see. So now this hydrogen peroxide is taken in a water bath first. How the water bath will be there means like this vessel will be there. Like this vessel will be there. Okay, in this vessel, what is taken in the sense water is taken. So here water is taken. Then into this we are keeping another vessel. Into this we are keeping another vessel like this. In this vessel we are taking this aqueous solution of H2O2. Then it is heated. Then it is heated. Okay. So now we are taking this hydrogen peroxide solution for careful evaporation of water. Careful evaporation of water. So if we heat like this, from this solution water is evaporating, not hydrogen peroxide. Hydrogen peroxide molecular mass is more, therefore its boiling point is more. For hydrogen peroxide, boiling point is higher than that of water. Hydrogen peroxide has higher boiling point than water. Why? Because hydrogen peroxide molecular mass is high. Therefore, it boils at a higher temperature, we can say. Sorry, water is evaporating. Therefore, concentration of hydrogen peroxide is increasing. So we are getting a 30% H2O2 solution now. Okay. So here we are heating hydrogen peroxide solution not directly through water bath. Why through water bath? In the sense, this water bath will give uniform heat to this solution. Direct heating means here heat will be more, here heat will be less. Non-uniform distribution will be there. Direct heating means. Water bath heating means uniform distribution of heat will be there. Okay, set. So we are getting 30% H2O2 solution we got. Then now we'll see the boiling point of H2O2. Boiling point of H2O2, how much? In the sense 152 degrees Celsius. Then we'll see boiling point of water. Boiling point of water 100 degrees Celsius. Now see, which is having higher boiling point? You see, hydrogen peroxide. Therefore, on water bath heating, water is evaporating but not hydrogen peroxide. Okay, so we got a 30% H2O2 solution we got. Next, this solution is taken for distillation under reduced pressure. So it is taken for distillation under reduced pressure. Distillation under reduced pressure. Then we are giving temperature less than 60 degrees Celsius. What is happening means water molecules are evaporating away. Then we are getting a 90% H2O2 solution. 90% H2O2 solution. So, how to go for distillation under reduced pressure? How to arrange the apparatus? That we will see. We are taking a round bottom flask. We are taking a round bottom flask like this. To this, a vacuum pump is connected. Here, vacuum pump is connected. Vacuum pump is connected. This vacuum pump, using this vacuum pump, what pressure we want to maintain inside this vessel, that pressure we can maintain. Sir, then here what we are taking in the sense that 30% H2O2 aqueous solution we are taking. Then we are keeping another tube here. Then we are closing this. Closed. This is this tube is connected like this. Connector like this. Then here water circulation in order to cool the pipe. Here water outlet, here water inlet. Okay. Now it is heated. Now using this vacuum pump, what pressure we want to keep here, that pressure we can maintain. Sorry. What pressure we want to keep? Reduced pressure we want to keep. That means the external pressure is not 1 atmosphere for this solution. For this solution, what is the external pressure? Above the solution, air will be there. That is exerting pressure. That is called external pressure for this solution. That external pressure should be less than normal. Normal is what? 1 atmosphere. Less than normal means that is called reduced pressure. Sir, now it is heating. Water is evaporating. That evaporated water is coming like this, condensing, and the water liquid we are collecting here. Where concentration of hydrogen peroxide increases. Concentration of hydrogen peroxide we are getting how much? In the sense 90% hydrogen peroxide solution we got. And we are providing how much temperature? Means less than 60 degrees Celsius we are providing. But boiling point of water is 100 degrees Celsius. But at less than 60 degrees Celsius itself, 30% H2O2 solution becomes 90% H2O2 solution, means most of the water molecules are removed, isn't it? How it is possible? Because the boiling point depends on external pressure. If you decrease external pressure, boiling point also decreases. If you increase external pressure, boiling point also increases. Sorry. We are keeping reduced pressure, therefore boiling point of water is decreasing, boiling point of hydrogen peroxide also decreasing. Why why we have to decrease the boiling point? Because hydrogen peroxide is unstable, it can decompose easily. Therefore, in order to keep hydrogen peroxide stable, we are reducing the boiling point. Okay, so on distillation under reduced pressure, we are getting 90% H2O2 solution. Then we are keeping this solution in ice crystals. In ice crystals we are keeping and allowed for cooling. So when we are keeping this solution in ice crystals, what happens means the water present in this solution becomes ice that can be removed. What is the remaining? Hydrogen peroxide crystals. So we are getting a hydrogen peroxide crystals we are getting. This is the method of concentrating hydrogen peroxide. This is the method to remove water molecules from hydrogen peroxide solution. Okay. Next step, decomposition of hydrogen peroxide we'll see. Hydrogen peroxide is unstable, therefore it decomposes easily to give water and oxygen. Here, in this case, oxygen oxidation number is -1. Here oxygen is -2. Here oxygen is 0. So -1 is converting into -2 means reduction. -1 converting into 0 means oxidation. Therefore, hydrogen peroxide undergoes disproportionation reaction. This decomposition. This decomposition is nothing but disproportionation, we can say. So now this reaction is catalyzed by which one? So which are acting as positive catalyst for this reaction? Positive catalyst is finely divided metals. Finely divided metals act as positive catalyst. Example is iron, copper, then plutonium, then platinum, gold. Next, MnO2, manganese dioxide. Next, metal ions, Na2 plus, Cu2 plus, etc. Metal ions. Then traces of bases, traces of bases present in the glass container. In the glass manufacture, we are taking some salts, we are taking sodium salts, we are taking. So the glass is a little basic nature will be there. So in the glass, bases will be there, trace of bases will be there. So if we store hydrogen peroxide in the glass vessel, due to presence of base, the hydrogen peroxide undergoes decomposition. Next, dust. Dust acts as positive catalyst. Therefore, if dust is there also, hydrogen peroxide undergoes decomposition. Now you say, why we are using hydrogen peroxide to clean the wound, to clean the nails, to clean the ear? Because where dust is there in the nails, where dirt is there only we will add hydrogen peroxide in order to remove dirt. On adding hydrogen peroxide to the place of dirt, hydrogen peroxide undergoes decomposition. Hydrogen peroxide decomposes to give water and nascent oxygen. This nascent oxygen, what it does means it removes the unwanted things. It is acting as a disinfectant, germicide, like this. Disinfectant, germicide, we can say. Sir, therefore, we are using this hydrogen peroxide, we are using, sir, because it is a mild disinfectant, it is a germicide, so we are using to clean the nails, to clean the ear, to clean the wounds, like this we are using hydrogen peroxide. Okay. Next, negative catalyst, which are acting as a negative catalyst for this decomposition, that we'll see. Negative catalyst. Negative catalyst. Negative catalyst is H3PO4, orthophosphoric acid. Next, ethanol, ethyl alcohol, C2H5OH, ethyl alcohol. Next, acetanilide, C6H5NHCOCH3, acetanilide. Next, glycerol. Next, urea. These substances act as negative catalyst for this decomposition. So anyhow, hydrogen peroxide we need, it is a medicinal substance. So we can use this hydrogen peroxide as a medicinal substance. So we have to, in the industry, hydrogen peroxide will be manufactured. That hydrogen peroxide should be sent to the medical shops. Then we will, consumers will use it. So this hydrogen peroxide is decomposing in the presence of base. That means we cannot store hydrogen peroxide in the glass vessel. It is decomposing in the presence of dust, in the sense that dirt should not be there. Then how to store hydrogen peroxide, how to pack hydrogen peroxide in order to send it to medical shops. So to store hydrogen peroxide, we have to use plastic vessel, we have to use plastic bottle, we have to use. Suppose if you want to use a glass bottle, you can use it, but give wax coating. Wax coating, give it. That means hydrogen peroxide will not be in contact with the glass, it will be in contact with the wax. So we can use plastic bottle. Otherwise, if you are using glass bottle, in the sense glass vessel, in the sense inside the glass vessel, give wax coating, you give it. Then add some negative catalyst. If you add some negative catalyst, what will happen means hydrogen peroxide will not decompose easily. So in this way only we have to pack the hydrogen peroxide. Okay. Next, what is the concentration of hydrogen peroxide solution? The given hydrogen peroxide solution concentration is what? What is the concentration term used to express the concentration of hydrogen peroxide solution? We already know that molarity, normality, molality, mole fraction, weight percentage, volume percentage, mass by volume percentage, these and all we know. Using that, we can express the concentration of a hydrogen peroxide solution. Another term also is there, particularly for hydrogen peroxide solution. What is the term in the sense? That is called volume strength. What is that in the sense? Volume strength. In the hydrogen peroxide solution, in the medical shop, when you are purchasing a hydrogen peroxide, you see the bottle. In the label, you see. In the label, what will be there means like this will be there. 10 volume hydrogen peroxide. Like this will be there. Here, this 10 always not 10. It can be varied. Okay, it can be varied. For example, I said 10. But rest of the things same. Suppose 10 is there, means 10 volume hydrogen peroxide will be there. What is the meaning of this means? The volume strength of hydrogen peroxide solution is 10. What is volume strength? Volume strength we want in the sense, what we have to do means, take this solution, you take one volume. You take one volume of this H2O2 solution you take. One volume in the sense you can take 1 liter or 1 ml or 1 unit volume, any you take. Okay, 1 ml of solution, 1 ml of this hydrogen, in this solution, 1 ml of hydrogen peroxide solution, or 1 liter of this hydrogen peroxide solution, like this you take. Otherwise, 1 meter cube of this hydrogen peroxide solution, like this you take it. Then this solution is heated. This solution is heated. What you will get means oxygen gas you will get. This oxygen gas, take this oxygen gas to STP condition. Okay, suppose this solution you are taking 1 liter. This solution you are taking 1 liter. This solution is heated. You are getting oxygen gas. At STP, you measure this volume, you will get 10 liter. Therefore, 10 volume is stored. Suppose if you take this solution 1 ml, you will get this oxygen at STP 10 ml you will get. If you take 1 meter cube, you will get 10 meter cube you will get. That's why this 10 is given. So volume strength 10 means that is a meaning. So volume strength, suppose 20 is there, otherwise 30 is there. Volume strength is 30. Volume strength is 30 means you take this solution 1 liter. You take this solution 1 liter and heat it. You will get oxygen gas. At STP condition, you measure this volume, you will get 30 liters. This is called a volume strength. So what is the meaning of volume strength we got? Now we will take a 100 volume H2O2. 100 volume H2O2. This commercial name is what means per hydrol. This commercial name is per hydrol. So per hydrol in the sense 100 volume H2O2 solution. This if you see mass percentage, mass by volume percentage, if you see it is coming as 30% mass by volume H2O2 solution. Okay, H2O2 solution. What is the meaning of this means 100 ml of this solution contains 30 grams of H2O2. That is the meaning. 100 ml of this solution contains 30 grams of H2O2. That is the meaning of this. This solution, you take 1 liter and heat it, you will get oxygen gas. How much oxygen gas you will get means 100 liters you will get at STP. That is the meaning of this parahydrol, we can say. So what is volume strength we got? So if you want to volume strength of hydrogen peroxide solution, what you have to do means take 1 liter of hydrogen peroxide solution. Then heat this hydrogen peroxide solution. You will get oxygen gas. Measure this volume at STP. So volume you are getting how much you see. Suppose you are getting a 25 liter. This is 1 liter. Here 25 liter of oxygen gas if we get,